Hello, and welcome back to Social Studies this week. So last week we talked about the Gutenberg printing press and all the changes it made during the Renaissance. Today we are going to talk about some scientific changes that happened during the Renaissance, specifically scientific thinking and what happened. So before the Renaissance happened and all the changes started happening, science was really based on myth. There was no scientific explanation for why things happen, and we pretty much just went along with what the church said. The church explained why things happen, and everyone believed in what the church said. And in fact, if you went against what the church said or questioned what the church said, it became very dangerous. You just needed to go along with what the church said. And if you didn't, that is what is called heresy. Heresy is the crime of believing or not believing what the church says, and you could get in some really big trouble for that. So it's really kind of surprising some of the things that the church taught. The church taught that the earth was flat. Of course, we know that's not true anymore. They also had a geocentric thing that they taught. And geocentrism means that the earth is at the center of the universe, and the sun and all of the stars and the planets revolve around the earth. They also believed that cutting into human cadavers or bodies was a terrible thing to do. So if someone died, they didn't try and find out why. They just buried the person. They also felt that if you got a disease, the only way really to cure it was to fast and to pray, and that really diseases were punishment from God, and everything happens for a reason, and we don't question it, we just go along with what God says, because he has a plan for us. And of course, we do still believe that, but we also believe that there are ways to fight disease and that there are ways to cure things. Well, during the Renaissance, scientists changed how humans viewed the world, and we really started looking at things in a very different way. One of the first scientists to challenge the church and the teachings of the church about the universe was Nicholas Copernicus. And he believed really that we were not a geocentric Earth, that things did not revolve around us, but rather that all of the planets revolved around the sun, which was the star in our universe. And that the star was the central part of our universe, and we, as well as the other planets, revolved around that. So he did risk heresy from the church and tried to prove that, in fact, the planets revolved around the sun. We call this heliocentrism, or heliocentric, where everything revolves around the sun. In this diagram, you can see how the sun, Sol, S-O-L, is located in the middle, and those circles that you see around the sun would be the planets that are revolving around the sun. And this is the heliocentric theory, where the sun stays in the middle and everything else revolves around it. Although Copernicus did not prove his theory, a very famous mathematician named Johann Kepler used math to prove that he was right. And in his proving that he was right, he proved that the planets actually did not move in circles, but rather they orbited in an ellipse, which is kind of a squashed circle that on one end stays close to the sun and in the other end goes out in a big arc away from the sun. And on the next screen, you'll see what that looks like. So these circles or ellipses that move around the sun are the pathways that the planets take around the sun. You'll notice not all of the planets are there. We couldn't see all of the planets yet through the telescopes, but you'll see that some of the planets are there, and Kepler was able to determine their pathways around the sun. You can see the math formulas underneath that he used to determine this. No, I cannot solve those math problems. If you can solve them, I think you need to run down and tell Mr. Taylor the next time you see him that you're able to do that math, because that would be awesome. I talked on the last slide about how we couldn't really see all of the planets, and that brings us to our next scientist, is Galileo Galilei. And Galileo agreed with Copernicus, and he also further proved the theory by inventing the first telescope. And basically what he did is he further improved a telescope that had been invented, a Dutch telescope that had been invented by putting glass on the end of two tubes. And he improved that telescope, and he was able to see more planets. He didn't see all of the planets way out at the end of our solar system, such as Pluto, which today is not a planet. But he was able to see Jupiter and some of Jupiter's moons and Venus, and he was also able to tell that, yes, they did orbit around the sun. So he also agreed with Copernicus and was able to prove it. Galileo also proved a lot of other scientific theories, such as gravity, and other important scientific theories. Sir Francis Bacon changed really how we look at science, and he created something that I know you are all very familiar with, and it's called the scientific method. In fact, you are all using it right now to work on your mini GOP. You didn't know this was going to turn into a science class, did you? So on this slide, you can see the different parts of the scientific method. We make an observation, we ask a question, we create a hypothesis, we test that hypothesis, we look at our data, we draw a conclusion, and then based on our results, we decide if we need to retest our hypothesis or if our hypothesis was correct. So I hope, in addition to doing your regular classes, you're all working very hard on your mini GOP. I can't wait to see how you've done on them. Another scientist that you've probably heard of is Sir Isaac Newton. He also worked with gravity. He discovered really the force and found out that all matter does fall at the same rate if it's in a vacuum, meaning there are no outside forces of it. So Galileo worked with gravity. He dropped things from the Leaning Tower of Pisa. He thought that if things were heavier, they would fall faster. He realized that they all landed at the same time. Sir Isaac Newton went and did further work on that. And on the next slide, you'll see one thing that he learned about how things needed to be in a vacuum with no outside forces to prove his theory that everything fell at the same rate. One of the experiments that Newton did was he dropped a feather and a ball. And if you just drop the feather and the ball in normal air, you know that the feather is going to take a long time to fall. It is not going to fall at the same rate as a ball. But if you put those two items in a vacuum and you drop them, the feather will fall at the same speed as a ball because it has no air currents to blow it around while it is falling. So Newton was able to prove that, yes, things will fall at the same rate because of the force of gravity. Everything has the same force of gravity, but that's because of the vacuum. So all of these scientific things were happening during the Renaissance because ideas were spreading. A lot of those ideas were spreading because of, oh yes, the Gutenberg printing press, and ideas were able to be spread much farther. People were also starting to question the church and not relying on everything that the church said. And when we get into next week, we're going to look more and more about what the church was saying and why people were questioning it. For your assignment today, you're going to complete an exit ticket based on this presentation. You're going to answer this quick check question in a paragraph. What caused scientific thinking to change and what major scientific breakthroughs occurred? So think about the different scientists that we talked about and the different things that they learned. There are 2 news ELA articles, one on Copernicus and one on Galileo. And I'm also just going to put up a little video about Galileo and how he was able to invent the telescope. I hope you have a great weekend. I hope that you and your families are staying safe. And if there's anything that you need, please feel free to email either myself or Mrs. Moore. Have a great weekend, and I will see you on Monday next week, because next week Social Studies and Science will have assignments on Monday, Wednesday, and Friday.